Imagine an artificial intelligence so powerful, it reduces global energy consumption more effectively than the combined efforts of over 10 million people turning off lights, switching to LED bulbs, and unplugging devices. That's not a hypothetical, it's already happening. And it's happening in the most unlikely place: the data centers that power our digital world. If you think AI is just about chatbots and deepfakes, you're missing the real story. Because this AI doesn't just predict, it optimizes. It doesn't just respond, it transforms. And it's saving energy at a scale that rewrites the rules of sustainability and tech. Hit that subscribe button, tap the bell, and like the video, because what you're about to learn might change how you think about artificial intelligence forever. This is Tech Mythos. Every time you stream a movie, send an email, or check your cloud storage, you're tapping into a global network of data centers. These facilities are the digital heart of our world, and they're massive energy hogs. In 2023, data centers consumed roughly 460 terawatt-hours of electricity globally, more than the entire United Kingdom. And demand is skyrocketing, fueled by everything from AI model training to real-time cloud gaming, autonomous vehicles, cryptocurrency mining, and the proliferation of IoT devices. Each of these trends contributes to an escalating need for high-density, always-on computing infrastructure. Now here's the twist. The very technology fueling this explosion in energy use is also the one solving it. Google, one of the largest data center operators on the planet, deployed an artificial intelligence system developed by DeepMind to tackle this exact problem. The AI uses reinforcement learning to control cooling systems inside data centers. In other words, it learns, on its own, how to optimize temperature and airflow to keep servers from overheating while using the least amount of electricity possible. And the results? Staggering. Within months of deployment, Google reported a 40% reduction in the energy used for cooling, translating to a 15% overall reduction in power consumption across data centers. That's equivalent to eliminating the entire electricity usage of a mid-sized city, just by making smarter decisions about airflow and temperature. Scaled globally, that translates into a meaningful dent in carbon emissions. But this isn't just about saving money or reducing carbon footprints, though it does both. It's about AI stepping into the real world, with real consequences, solving problems human engineers couldn't crack at scale. Traditional methods relied on human operators adjusting parameters manually. But data centers are complex systems with countless variables: humidity, server load, weather conditions, fan speed, air pressure. No human could possibly account for all of them simultaneously in real time. The AI can, and it does it without fatigue, without guesswork, and without bias. Here's how it works. The AI is fed a continuous stream of data from sensors throughout the facility: temperature, energy draw, humidity, airflow. It models the data center in real time, then uses deep reinforcement learning to simulate thousands of possible configurations before settling on the most efficient one. And it does this every 5 minutes. Continuously, flawlessly, learning as it goes. The system even flags anomalies such as equipment degradation or system inefficiencies long before they become major issues. And Google isn't alone. Microsoft has launched a similar initiative, integrating AI into its Azure data centers to manage energy, reduce latency, and even predict hardware failures before they occur. Amazon Web Services is deploying machine learning models to shift workloads dynamically based on energy prices and renewable availability, essentially allowing data centers to follow the sun and use green energy when it's cheapest and most abundant. These companies are now leveraging AI to optimize not just internal efficiency, but external energy relationships, working in concert with utility providers to ensure maximum uptime with minimal footprint. This isn't about one AI saving energy, it's about a global shift toward intelligent infrastructure, and it doesn't stop at tech companies. AI is now optimizing energy grids themselves. In the US, startups like AutoGrid and GridX use AI to predict demand surges, adjust energy pricing, and distribute loads more evenly. In Europe, AI platforms help balance wind and solar fluctuations by coordinating storage and backup systems with real-time weather modeling. Across Asia, smart grid pilots are using AI to prioritize energy routing to critical services during natural disasters. Think about that. We've built a machine that watches the sky, listens to the wind, and reroutes energy before a blackout even begins. Imagine an entire city grid operating like an intelligent organism, self-correcting, adaptive, and aware of both macro-scale weather systems and micro-scale usage changes from individual homes and businesses. But back to data centers, because that's where the story gets even more impressive. NVIDIA, the hardware powerhouse behind most modern AI chips, is developing AI that not only helps train models, but also improves the power efficiency of its GPUs dynamically. So the chips training your AI are using AI to reduce their own energy footprint. It's a recursive loop of optimization, and it's scaling fast. Other manufacturers are following suit, embedding AI into chipsets themselves for real-time load balancing and predictive cooling. Let's put this into perspective. The average household in the US uses about 10,500 kilowatt-hours of electricity per year. Multiply that by 10 million households and you get 105 billion kilowatt-hours. Google's AI systems, when deployed at global scale across all their data centers, are estimated to save enough energy annually to offset this kind of usage. And that's just from cooling optimization. Now factor in compute scheduling, traffic shaping, storage allocation, and hardware wear and tear prediction, and you begin to see how much energy can be recovered across the entire stack. It's like removing 10 million households from the grid without asking anyone to change a single habit. No behavioral campaigns, no energy rationing, just intelligence applied at scale. And this matters, because as AI adoption grows, so does its energy appetite. Training GPT-4, for example, consumed an estimated 1.2 gigawatt-hours of electricity, the equivalent of about 1,000 US homes for a year. Multiply that by hundreds of models and you get a serious environmental issue. But the same AI technologies that consume power can also be the solution, when applied with intention. It all comes down to what we optimize for: performance, cost, or sustainability, or all three simultaneously. Here's something even more futuristic. AI isn't just optimizing digital systems, it's merging with hardware in entirely new ways. Companies are developing edge AI chips that adapt their energy draw based on workload in real time. That means smart devices from thermostats to industrial robots that sip power instead of guzzling it. Buildings with embedded AI can reduce HVAC consumption by up to 30% just by learning occupants' behavior. And the most radical development? Neuromorphic computing. These are AI chips designed to mimic the human brain's energy efficiency. The human brain runs on about 20 watts, less than a light bulb, and yet can outperform today's largest AI systems in flexibility, pattern recognition, and adaptability. Neuromorphic chips like Intel's Loihi or IBM's True North are pushing this frontier, using event-driven processing instead of brute force computation. It's AI that thinks more like us and uses energy like us too. The implications for mobile computing, robotics, and embedded systems are enormous. Meanwhile, Tesla is experimenting with Dojo, a supercomputer built from the ground up to train AI models more efficiently. Early tests suggest it could reduce training time and energy costs by up to 75% compared to traditional systems. That's not just a win for Tesla, it's a blueprint for the future of AI development itself. Companies like Cerebras and Graphcore are also building purpose-built AI hardware that dramatically outperforms traditional setups on both speed and sustainability. Midway through this transformation, it's worth asking, why hasn't this story gone viral? Why aren't more people talking about the fact that AI is solving one of humanity's most urgent crises, our unsustainable energy usage? The answer might be that we're too distracted by the loudest narratives. We focus on what AI might destroy, but ignore what it's already saving. That narrative must change, and it starts with informed conversations. So, if you've made it this far, you're not just curious, you're awake. And this is where you come in. Share this video, talk about it, because every conversation shifts the narrative. Every like and comment amplifies the signal over the noise. And we need that, desperately. The more attention we give to AI's positive impact, the more investment and innovation it will receive. Now let's take this one step further. Imagine an AI that doesn't just optimize for energy, but for planetary health. One that can coordinate carbon capture systems across continents, one that tracks biodiversity in real time via satellite and drone footage, one that identifies the most efficient reforestation sites, and then directs robotic planters to do the work. This isn't science fiction, it's already in development. Add in genomic AI that identifies plant species most likely to survive in changing climates, and you have the future of reforestation at your fingertips. The AI startup Pachama, for instance, uses satellite imagery and machine learning to validate carbon credits more accurately than ever before, ensuring that companies investing in sustainability are actually making a difference. In essence, AI is becoming the accountability layer of our environmental efforts. Others, like Climate AI, are using predictive models to forecast climate risk decades in advance, enabling better policy and investment decisions. In South Korea, a city called Songdo is already functioning as a partially AI-managed smart city, where traffic lights adjust dynamically to reduce congestion, and power flows are routed to minimize waste. These aren't isolated projects, they're testbeds for what's coming next. As these experiments scale, we'll see entire urban ecosystems running on predictive intelligence, optimized for both efficiency and resilience. Because the next version of our world won't be built with concrete and steel alone. It will be built with intelligence, layered into everything, invisible, silent, but transformative. The cities of tomorrow won't just be smart, they'll be conscious, adapting to the rhythm of human life and natural systems in harmony. And that brings us back to the core idea. This AI saves more energy than 10 million people can, not by being better than us, but by supporting us, augmenting our systems, and making our world run just a little bit smarter. This is the AI-powered world we need, not one of domination but one of alignment. The future isn't one where we all unplug and go dark, it's one where we plug into intelligence, and let it do what it does best, not replace us, but elevate us. If this vision resonates with you, it's time to act. Subscribe, like, and share this video. Join the movement that sees AI not just as a tool, but as a partner in sustainability. Because when intelligence meets intention, there's no limit to what we can save or create. This is Tech Mythos.